of our RPKI week, and we were set to have a series of presentations, but then in the end, not all of them came through. But today we have Melchior from Juniper, Melchior Elmans from Juniper, moderating the session. I will hand it over to him, and you will see me later with a big final part of the day today. So I hope you enjoy what we have in program for you today, what we have prepared, and I talk to you later. So Melchior, welcome.
Thank you, Max. So as Max said, welcome to the last day of RPKI Week 2022, organized by the Internet Society. Today we'll discuss the future developments in routing security. My name is Melchior Elmans. In daily life, I work with Juniper, and I very much support routing security. So thanks for having me today as a moderator. Housekeeping, please, if you have questions, save them for the end of the session. You can ask your question live or ask it in the chat, and I will relay them to the presenter. The presentation today is from Professor Dan Lee, who is a professor in the Department of Computer Science and Technology at Tsinghua University, where he leads the Network Architecture System and Protocols Research Group. After Professor Dan's presentation, Max will come back with a quiz about RPKI routing security, BGP Alerter, and some questions about earlier presentations from this week. So make sure your knowledge is on par. But before we go to the quiz, I would like to ask Professor Dan Lee to take over and start his presentation about towards more accurate source address validation in the internet, in other words, SOFNet. Dan, are you ready?
Yeah, so can you hear me and see my slides?
Yes, we hear you, but your slides are not yet in presenter mode. Yes, there we are. Thank you.
Okay, so is everything fine?
Yes, perfect. Go ahead.
Okay, so good afternoon or good evening, everyone. I'm Dan Lee from Tsinghua University. It's my great honor to give a talk in the RPKI week. The title of my presentation today is about towards more accurate and more incentive source address validation in the internet. First, I will introduce some background knowledge. We all know that source address validation, or SAV, is important and challenging in the internet. First, we know that source address spoofing can lead to various malicious attacks represented by reflective DDoS attack. So network devices deploy SAV mechanisms to permit traffic with valid source address and block traffic with invalid source address. Since the year of 2014, the Malus initiative is calling on network operators to implement SAV as close to the source as possible. However, SAV is also challenging. We need to guarantee the accuracy of source address validation to avoid improper block and reduce improper permit as much as possible. We also need to provide incentive to the deployers because it is a high possibility that the SAV mechanisms will be partially deployed. When it is partially deployed, we hope that the deployers can get benefit from the deployment. And we also need to consider the cost. That is, the deployment cost of SAV mechanisms should be affordable. In RFC 6 line, 5 line, the authors will document the potential attacks coming from source address spoofing. The most typical attack by source address spoofing is reflective DDoS. We use this figure to show the attack. There is an attacker in S1 which sends a request traffic to S2 by forging the source addresses of S3. When the reflective server in S2 receives this request, it will respond to this traffic by sending traffic to S3. So in this case, S1 is the attacker and S3 is the victim. And other potential attacks include a single packet attack, flood-based DDoS, poisoning attacks, spoof-based worm or malware propagation, accounting subversion, man-in-the-middle attack, as well as third-party hacking. SAV is also a problem with long history of attention in IETF. As early as 1998, in RFC 2267 and RFC 2827, ingress filtering or ACL-based SOF was proposed, but it has the problem of manual configuration. In the year of 2004, RFC 3704 proposed a strict URPF and a feasible URPF, but it has the problem of improper block under asymmetric routing. In the same RFC, feasible URPF and loose URPF were also proposed, but it has a problem of improper permit. From the year of 2012 and 2017, IETF created a SAVI working group with the focus on host-level SAV in access networks or enterprise networks. The most recent effort in IETF about SAV mechanism is RFC 8704, which proposed the EFP URPF or enhanced feasible path URPF. It mitigates the problem of strict URPF and feasible URPF in some cases. However, it is still necessary to propose new intradomain and interdomain SOF mechanisms. RFC 5210 proposed the SAVA architecture, which divides the SAV into 3 check-in levels, namely access network SAV, intradomain SAV, and the interdomain SAV. Let's first say the access network SAV, that is SAVI. So the SAVI architecture just enables a host-level validation of the source address in access networks. But the problem is that the number of operators for access networks is very huge. So it is difficult to require all access networks to deploy SAVI. When some access networks do not deploy SAVI, intradomain and interdomain SOF can help filter spoofing traffic as close to the source as possible. So that is why intradomain and interdomain SOF mechanisms are necessary. However, existing URPF-based technologies for intra and interdomain SOF is not enough because, as aforementioned, strict URPF, feasible URPF, and loose URPF have well-known improper block or improper permit problems, and the EFP URPF does not completely solve the problem. Next, I will present the gap analysis of existing SAV mechanisms as well as the requirements for a new intra and interdomain SAV mechanism. Let's first discuss the intradomain case. This figure shows a typical intradomain scenario. This is a single AS, but it has 3 operators with area 0, area 1, and area 2. This is the typical example in CERNET or Child Education and Research Network. In this scenario, area 1 and area 2 represent a different campus network, and area 0 is the operator of the CERNET, but they are located in the same AS. So we assume that in this scenario, both area 0 and area 1 deploy SAV mechanisms, but area 2 does not deploy any intradomain SAV mechanism. Specifically, router 1, router 2, and router 3 deploy strict URPF or ACL, while router 9 and router 10 deploy strict URPF or loose URPF. All these mechanisms are existing intradomain SAV mechanisms defined in IETF. So in this kind of deployment scenario, there are several problems. The first problem is about the improper block. Let's focus on subnet 1 with the prefix of 166.0.0.0/16. It has multi-router access. That is, it simultaneously connects router 1 and router 2, but it only advertises half of its prefix to router 1 and the other half of the prefix to router 2. So router 1 and router 2 only maintains half of the prefixes of subnet 1 in its fib table. In this case, subnet 1 can send traffic with whatever source prefix source addresses to router 1 or router 2. So if router 1 or router 2 applies strict eRPF, in this case, there will be improper block problem because the fib table of either router 1 or router 2 only has incomplete information. But if they apply ACL or ingress filtering mechanism in the corresponding interfaces, we have to make manual update if there is a prefix update or topology update for subnet 1. So in any case, the manual effort are just the cost we want to avoid. There is another scenario for improper block. Let's focus on the communication between subnet 1 and subnet 2 with the prefixes of P1 and P2 respectively. Based on the routing configuration, the forwarding path from P1 to P2 is router 1, router 9, router 10, router 5, router 6, and router 7. While in the other direction, the forwarding path from P2 to P1 is router 8, router 10, router 9, router 4, router 3, and router 2. So this the forwarding paths for the two subnets are just asymmetric. So in this case, if router 10 applies strict eRPF, the legal traffic from subnet 2 will be improperly blocked. But if router 10 applies loose eRPF, the traffic from subnet 2 can use spoofing source address, and it can still pass the checking. So this is another case of improper block. The second problem is about the misbehaved router. Let's focus on router 3 and subnet 3 in this figure. If router 3 misbehaves or is compromised, which means that router 3 cannot correctly conduct the sub functionality. In this case, the spoofing traffic from subnet 3 cannot be blocked by downstream routers such as router 4, because router 4 does not connect any sublets, so it does not conduct the soft checking based on the ingress filtering defined in the RFCs. The third problem is about the misaligned incentive. We said that in this scenario, everyone deploys SOF, while every 2 does not deploy SOF. It means that everyone cannot use every 2's source address to visit other network, because this spoofing traffic will be filtered by router 1, router 2, or router 3. However, every 2 can use every 1's source address to visit other networks, because every 2 does not deploy any SOF mechanism at all. It means that subnet 1 can be attacked by subnet 2 by reflective DDoS, or means that the deployed area cannot be protected from being attacked by undeployed area. So it hurts the incentive for the operators to deploy the SOF mechanism. Based on the gap analysis, we have the following requirements for a new intra-domain SOF. Number 1 requirement is that the SOF mechanism should discover the real data plane forwarding path among routers so as to avoid improper block under asymmetric routing. And the number 2 requirement is that the soft mechanism should be deployed in more routers than only the first of the router, so as to increase the resilience against routers' misbehavior. And the number 3 requirement is that the soft mechanism should disseminate the source prefixes of deployed areas as far as possible, so as to have block traffic which spoof these source prefixes as close to the traffic source as possible. And if we can do this, we can provide incentive to the deployed areas. Then let's discuss the inter-domain scenario. We also use a typical figure to show as an example. In the figure, there are 5 ASs. AS1 has 2 providers, S2 and S3. S2 has a provider that is S4, and S3 is either a customer or a peer of S4, while S4 again has a provider that is S5. In this case, S1 only advertises its prefixes to S3, but it does not advertise the prefixes to S2. And for the 7 mechanism deployment, only S1, S2, and S4 deploy the inter-domain soft mechanism, which is EFP URPF defined in RFC 8704. And S3 and S5 do not make the deployment at all. So it is notable that EFP URPF only works in AS border routers for inbound traffic. It has 2 algorithms. For algorithm A, each customer interface independently learns the prefix advertised by BGP update message. For algorithm B, all the customer interfaces will share the learned prefix information with each other. It also has several problems. The first problem is about the improper block. Let's assume S1 sends traffic to S4 along the paths of S1, S2, and S4. Well, it is notable that S1 does not advertise its prefix towards these paths. So if S4 runs EFP URPF algorithm 1, its customer interface, that is interface 1, does not learn the prefix of S1. So it will improperly block the traffic. But if S4 runs EFP URPF algorithm B, then it depends on the relationship between S3 and S4. If S3 is a customer of S4, the 2 customer interfaces will share information with each other, so there will be no problem. But if S3 is a peer of S4, then the interface 1 cannot get the information from the other peer interface. So it will still have improper block problem at this customer interface 1. The second problem is about ineffective defense. Let's suppose an example of a reflective DDoS attack. The attacker is located in S5. It just sends traffic to S4 by forging the source address of S1. So in this case, when S4 receives the illegal traffic from S5, it cannot block the traffic because EFP URPF does not work at its provider interface. So in this case, even though S4 deploys EFP URPF, it cannot effectively defend the reflective DDoS attack. The third problem is about misaligned incentive. Still in this topology, let's consider 2 possible reflective DDoS attack. In the left figure, an attacker in S5 sends traffic to S3 by forging the source address of S4. It means that the victim is S4. So in this case, since S4 cannot check the source address in its provider interface, the attack will succeed. But in the right figure, if the attacker in S2 sends traffic to S4 by forging the source address of S5, since the traffic will come at the customer interface of S4, they can be correctly filtered, so the attack will fail. It means that S5 cannot reflective DDoS attack for S4, while S2 cannot non-reflective DDoS attack for S5. So it means that the deployed ASs are not protected from being attacked by undeployed ASs. So although S4 deploys EFG RPF, it just defends the attack against S5, but it cannot defend the attack against itself. It means that the ASs cannot get benefit from deploying self mechanisms. So this is misaligned incentive. Based on the gap analysis above, we have the following requirements for a new inter-domain solve mechanism. Number one requirement, the solve mechanism should discover the real data plane forwarding path among ASs so as to avoid improper block under asymmetric routing. And the number two requirement is that solve mechanism should enable all direction validation, because EFG RPF only works in customer or peer interface, but most attacking traffic comes from remote ASs via provider interface. And the number three requirement is that the solve mechanism should disseminate the source prefixes of the deployed ASs as far as possible, so as to help block traffic which spoof these source prefixes as close to the traffic source as possible. And so we can provide incentives to the deployed ASs. Next, I will describe our servlet solution. The basic idea of a servlet includes the following. The first about resilience. Each router will build a subtable to validate the source addresses of incoming traffic. If the prefixes are not learned in the subtable, okay, here prefix means the source address. If the source address are not learned in the subtable, the incoming packet will be permitted. But if the source addresses are learned in the subtable, while the incoming interface of the packet does not match, the packet will be blocked. So it can provide more resilience than single hop checking and ingress routers. The second is about the correctness. So the router's subtables should follow the real forwarding path in data plane, so as to ensure correct validation even with asymmetric routing. That is also what servlet wants to achieve. The third is about incentive. The source prefixes of the deployed areas will be disseminated as far as possible, so as to mitigate reflective DDoS attack targeting at these source prefixes and filter the illegal traffic forwarding these source prefixes as close to the traffic source as possible. The fourth is about the cost. In servlet, we only extend existing control plane protocols without any data plane packet modification, so it will not affect the performance in the data plane. So by deploying servlet, each router will have a soft table, and the incoming packets will be first be checked by the soft table for its source address. If it passes the source address validation, it goes to the FAPE table to decide the forwarding interface. The servlet protocol architecture to generate the soft table is like this. It will discover the real data plane forwarding path, where a hop-by-hop prefix notification mechanism, and generates the soft tables in routers along the path. It separates the protocol into an intra-domain part and an inter-domain part, both sharing the same high-level architecture idea. To describe the workflow of a servlet protocol, we define some terminologies here. A node means either a router in intra-domain servlet or an AS in inter-domain servlet. Prefix notification means the process by which a node notifies the incoming direction of its source of prefixes to all the other nodes in the network. And during the prefix notification process, each node conducts one of these three operations. The first is the message origination. that is a node generates the original notification message. The second is a message relay, that is a load generates a relaying notification message after receiving a notification message. And the third is a message termination, that is a load will terminate the received notification message and does not relay it further. There are two major messages in servlet notification. The first is the two main fields. The first is about the source prefix field. This field contains the source prefixes of the initial node. When receiving a notification message, the node will generate sub-rules for the source prefixes in this field. And this field remains unchanged during the prefix notification process. The second field is the propagation scope field. This field contains a list of destination prefixes, which takes the neighboring node as the next hop from the fib. And this field is used to discover the real data plane forwarding path, and it changes hop by hop during the prefix notification process. Then I will use an example to show the subnet protocol workflow. In this figure, we have 7 nodes. It means either 7 routers in an intra-domain network or 7 ASs in the intra-domain network scenario. And the fib of node 1 is shown in this table. So the process of prefix notification for P1 is the source prefix of node 1. It's just like this. Node 1 will conduct message origination since P1 is its own prefix. Node 1 will first look up its own fib. It finds that the destination prefix of P2, P4, P6, and P7. These prefixes are the source prefix of the other nodes in the network. These 4 prefixes take node 2 as the next hop. So node 1 will generate an original notification message to node 2. And the message just contains the source prefix of P1 and the propagation scope of P2, P4, P6, and P7. At the same time, node 1 also finds that from its fib, P3 and P5 take node 3 as the next hop. So node 1 will generate an original notification message to node 3 with the source prefix of P1 and the propagation scope of P3 and P5. It is notable that in this case, although node 7 is a neighboring node of node 1, from node 1's fib table, there are no destination prefixes taking node 7 as the next hop. So node 1 will not send any notification message to node 7 at all. When node 2 receives the notification message from node 1 at the interface of 2.1, it will just generate the sub-rules in its sub-table for the source prefixes P1 learned in the notification message and set the incoming interface as 2.1. After that, node 2 will make the message relay. From node 2's fib table, it finds that it receives the propagation scope includes P2, P4, P6, and P7. But P2 is the prefix of node 2 itself, so it just removes it. For the 3 remaining prefixes, P4 and P6 take node 4 as the next hop from the fib table. So node 2 will conduct a message relay and generates a relay notification message to node 4 with the source prefix of P1 and the propagation scope of P4 and P6. And at the same time, node 2 finds that P6 and P7 also take node 7 as the next hop from the fib table. So it will also generate a relay notification message to node 7 with the source prefix of P1 and the propagation scope of P6 and P7. It is notable that in this case, there is a multipath routing towards the destination prefix of P6, and our mechanism can naturally support it. Again, when node 4 receives the message from node 2 at the interface 4.1, it just directly generates the sub rule in the sub table by setting the incoming interface of source prefix P1 as the interface 4.1. And from node 4's feed, the prefix of P6 take node 6 as the next hop. So node 4 will conduct message relaying by generating a new relaying message, which takes P1 as the source prefix and P6 as the propagation scope. It is notable that although the propagation scope in the message received by P4 includes both P4 and P6, the prefix of P4 is a source prefix of node 4 itself, so it will just remove it. And when node 7 receives the message from node 2 and the interface of 7.1, it will make a similar operation by setting the incoming interface 7.1 as the incoming interface of source prefix P1. And it also generates a relaying message towards node 6 by looking up its fib table. And in this case, node 6 will receive two separate notification messages, one from node 2 at interface 6.2, and the other from node 7 at interface 6.1. And node 6 will just generate the sub-rule in the sub-table by setting the two interfaces both as the valid incoming interface of source prefix P1. And node 6 will just terminate this relaying message because P6 in this propagation scope is its own prefix, and there are no other prefixes in the propagation scope at all. In the other path, node 3 will just make a similar operation, and I will not just go to the details, just omit it. So what we describe above is about the regular operation of SOFNet protocol architecture. Given routing or network topology dynamic, SOFNet protocol will just support update. We have two kinds of update mode. One is periodical update. That is, each initial node will generate put the notification message periodically. And the other is triggered update. That is, when there is routing state change or topology change, the initial node will generate protocol messages to add the updated sub-rules or delete outdated sub-rules for the affected loads. And we suggest the inter-domain subnet supports both periodic and triggered update, while inter-domain subnet only supports triggered update. Finally, I will briefly introduce the subnet working group, which was just formed last month in IETF. In IETF 113, we successfully had a subnet BOF. I was just one of the proponents of this BOF. And after this BOF, we have a very active discussion about the intra-domain and inter-domain just functionalities just in the mailing list. And in June 17, the IESG approved the formation of a new working group for intra-domain and inter-domain source address validation. That is a subnet working group. We belong to the routing area because the focus of this working group is how to extend existing IGP or BGP routing protocols to support support building an independent subtable in the routers by the basic architectures which I described just now. We have a mailing list, subnet and IETF.org. We hope that the colleagues from Manos can also join the mailing list and discuss more details with us. And this should be July 25th, not May 25th. Just in July 25th, in the IETF 114 meeting, we will have the first working group meeting of the subnet working group. We also invite the colleagues from Manos community just can join us. That is all for my presentation. Thank you very much.
Thank you very much, Dan. I indeed already just joined the SafeNet mailing list. Thanks for pointing that out. What are the next steps? So you have a meeting in the next IETF meeting. You have a working group meeting, but I did not see any documents yet. Is there things you would invite any of the participants today to collaborate on, or how can people get involved?
Yeah, actually the deadline of the document submission is July 13. We are still actively working on the documents. We will submit the documents in the next few days, and we will also just share the information in the mailing list. After that, we can have more to discuss. So I encourage colleagues to join the mailing list, and then we will learn more information. Thank you.
All right, thank you. Are there any questions from the group? I see Tony just posted a question. How do you predict the amount of low-level programming between brackets to interface logic compared to what is typical today?
Yeah, I'm not sure whether I fully get the question, but generally speaking, for the SafeNet work, we only just make extensions for the IGP or BGP routing protocols in the control plane. We do not touch the data plane packet behavior. I admit that we will do some kind of programming for the interface logic, but for my understanding, all these kind of control plane functionalities, its purpose is to provide high performance and more secure and better service for data plane traffic. So I think the cost of in the control plane should be affordable if we can provide a better data plane for the applications and for the users. Okay, that is my understanding. Thank you.
I see Tony added a comment to clarify the question, I suppose, asking how difficult it would be to do SafeNet data plane programming with existing hardware that is deployed.
Okay. Then I think I get the right question. Yeah. Actually, we already have a prototype router to implement the SafeNet data plane. And the only cost is that we will add a sub table, in the routers. Today, actually, in the data plane, routers already have the FIP table, the ACL rules, and other chips, in the data plane. And we need to add a sub table, in the data plane. And if the subnets are widely deployed in the internet, the size of the sub table should be similar as the FIP table. But we know that for many entries in the sub table and the FIP table, they're just the incoming interface and the outgoing interface for a prefix just as a scene. So maybe we can just share some space. Then we can just significantly reduce the cost in the data plane. So yeah, that's the cost that we have to pay in the data plane. As for the programming, difficulty, at least from the prototype we have currently developed, we think that it's affordable. Yeah, thank you.
Another question from Renata. Do you consider using P4 devices to implement SafeNet?
Yeah, that is a good idea. I think we will not just limit the data plane implementation to any specific hardware platform, P4 will, of course, be a wonderful choice because it has high programmability. Yeah.
All right. Next question from Georgius. Do you expect that SOFNet requirements will require the specification of a new control plane protocol, or an extension to an existing protocol can satisfy the requirements that you mentioned?
Yeah, this is a great question. Actually, we have widely discussed this topic in the servlet mailing list. For current comments from the IETF community, most people think that a better way is to extend an existing control plane protocol. For example, the servlet protocol have intra-domain part and inter-domain part. For intra-domain part, maybe we will just extend an existing IGP protocol, SPF or EZs or Rift for data center network, or even BGP SPF for this kind of routing protocols. So for inter-domain part, of course, we only have one choice, that is BGP. And even for extending BGP, actually we have many choices. We maybe add a SAFI or add or just AFI. So there are different choices. So the specific extension details for the existing protocols are going to be widely discussed in the working group. But the general consensus in the working group now is that we will extend existing routing protocols. That is also the put this servlet working group in the routing area in the IETF. Yeah, thank you.
All right, thank you all for your questions. With that, I would like to close the line. Dan, thank you very much for your really interesting presentation. Please come back next year to update us on how you're going with the SOFNet working group and the work you are doing. So thanks again.
Okay, thank you very much.
With that, I would like to hand it over to Max for the quiz. I just heard that the prize you can win is eternal bragging rights about your knowledge of routing security. So with that, Max, please go ahead.
Thank you, Melchior. Yes, the prizes you can win are eternal glory, but also there is a remarkable, the very nice tablet. I have one of them as well, has a prize coming up. So let me start sharing my screen. We'll share my screen with sound, and that has to be Kahoot. Let's start it in classic mode. This is a quiz that will happen. This is the pin. And what I'm suggesting you is to get out your phone, get out your maybe a browser, and go to kahoot.it, the URL up here, and put this game pin. And then you join the quiz with us. So I see we have, let me check. Let me open the participants list. We have 52 participants, so I would expect to see more than 3 people here on the list. We have 5, 6, 7, 8. Yes, Melchior as well. Melchior looking for glory. This will be a quiz about, as Melchior mentioned, routing security, RPKI. Some questions are, of course, way harder than others. But if you've paid attention in the last few days, if you've seen how RPKI works, it should be relatively quick, relatively simple for you. Okay, I see 19 participants. We're almost halfway through the 51 we have on the call right now. I'll give you a few more seconds to join. And then I'll start the, okay, 19, 20. Yes, let's try to get to 25. Let's try to get at least to half of the room. Come on, you're giving up a chance to win a remarkable. Very nice tablet.
I also see we can win t-shirts and other assorted prizes according to Megan.
Yes, I didn't want to promise more than I could, but yes.
But I'm a little worried that everyone is afraid of your questions, Max.
No, the questions will be relatively simple. Don't worry. They are also fun. I'll give you another few seconds, as I see we have 21 people so far. Then I can try to start the quiz. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's start. I see we have 21 participants. Let's start with the quiz. You will see the questions on the screen, and then on your laptop or your phone, you will see the possible answers, and then you'll have to click on the correct answer there. What is the meaning of the RPKI acronym? We'll start with something simple. Is it retaining public key infrastructure? Is it routing public key infrastructure? Is it resource public key infrastructure, or realizing private keys for the internet? Which one of these is it? Okay, I see that the majority picked the correct answer. It's resource public key infrastructure. It's always tricky, and I know it because it becomes normal to say routing public infrastructure, but in the end, we're certifying resources. Let's see who is on top, and don't forget that it's not just important to answer, but to do it in the quickest way possible. So on top, we have TDK, we have Felix, and then Melchior. But very, very close, we have Simon and RTR. Okay, ready for the next question. Question 2 of 15. What are the 4 manners actions for ISPs? Is it RPKI, anti-spoofing, DDoS mitigation, filtering, anti-spoofing, coordination, and global validation? Or URPF, DDoS mitigation, filtering, DNSSEC, or last, filtering, anti-spoofing, global validation, discussion. Okay, good. It's filtering, anti-spoofing, coordination, and global validation. I know the green one was tricky because it was very close, but discussion is not part of the actions. It's something that's nice to do, discuss about routing security, but not exactly something that's mentioned in manners. So let's see if anything changed on the top. Oh, I see Melchior lost the first position, one of the first positions, but Felix, Simon, and Emil Void are all very, very close to each other. So there's a good chance we have a nice competition at the top. Ready for the next one? Let's go. What's the meaning of the ROA acronym? Is it resource object authorization, route origin authorization, route object authorization, or round object authorization? Good, it's route origin authorization, not route object authorization, where route objects are part of the IRR system, not in RPKI. Good, but I see the majority got it right, which is good. I see the 2 positions on top didn't change, but we have some new chasers, NPM, Tony, and Travis. Ready for the next one. This is a multi-selection. What protocol can be used to download the RPKI data from repositories? You can choose multiple ones. Is it UUCP, rsync, RRDP, or SMTP? This is relatively easy. Well done, well done. Besides those who chose UUCP, not used for RPKI, but rsync and RRDP are correct. Let's see if anything changed on top. Oh, Simon took the lead. Felix was just a little slower. And then Tony joined them on top with MPM and Travis. So let's go on to the next one. We're 1/3 of the way. What is the name of the software developed by Massimo Candela? Is it BGP Messenger, BGP Alerter, RPKI Analyzer, or BGP Alerting? This should be quick and relatively easy to answer if you followed in the previous days. Well done, it's BGP Alerter. It's a tool to help you monitor the BGP announcements out of your network. Did anything change on the top? Not really. So Simon is still leading, followed by Felix and Tony, and then a little behind we have TDK and SM. Okay, let's see. Battle for the top. Next question. Which file types are not found in an RPKI repository? What can you not find in an RPKI repository? Is it CRLs, list of resources in plain text, manifest files? What you cannot find in an RPKI repository is the list of resources in plain text. You don't have that. Those are everything is included in other types of files. So we have Simon on top, Felix losing a little bit, staying a little bit behind, Tony on fire with 6 correct answers in a row, and then we have a little bit of a distance for TDK and RTR. Okay, let's check the next question. Can RPKI ROAs overlap? No, yes, only more specifics, only less specifics. This can be tricky, huh? This can be a tricky, well, not tricky question, but tricky answers we have here. They can overlap. It's not just for more specifics or less specifics, but ROAs can simply overlap. Well done. I see the majority got it right. Aye, Simon. Simon, you didn't get it right, unfortunately. You lost the first position, but there's still a chance to catch up for you and all the others. It's a very close game. So the next question. What's the name of the relying party software written by NL NetLabs? Is it Routinator, Routinator 9000, Octo RPKI, or RPKI Client? Okay, Routinator, well done. Routinator 9000 is not correct. If you really wanted to say something specific, it was Melchior's Routinator 3000, but that was the original name, and then it was changed just to Routinator. Let's see who's on top now. Oh, Tony lost the top, but then you're still very close to Felix, Simon, and TDK. So next question is up. What information does a ROA contain? Oh, well done. The address range, the originating SN, and the max length. I see that everyone got it right perfectly. So who was quicker? Ah, well done, well done. Nothing changed on top. So next question. What protocol can be used to download the RPKI data from repositories? Is it UUCP, rsync, SMTP, RRDP? Well done, well done. It's either rsync or RRDP, with RRDP being preferred because it's better, more secure, and doesn't overload the servers and can be any cast. So anything changed on top? Not really. We see Felix gaining a little bit of advantage over Simon, which is very close to TDK and Tony, and then a little bit behind we have SM. Next question. What is the abbreviation for SLURM? Is it Secure Legal Internet Number Resource Management? Secure Local Internet Number Resource Management, Simplified Local Internet Number Resource Management, or Simplified Legal Internet Number Resource Management? Let's see how this goes. It's Simplified Local Internet Number Resource Management, not secure. Ha, this was a tricky question. Let's see if anything changed on top. We see TDK getting to the top, and Felix and Simon still following. Good, good. So let's move to the next question. If you create a ROA for /21 with max length 21, the announcement for the /24 is unknown, undefined, valid, or invalid? Look at the prefix, look at the max length. Does the /24 fit in there? And if it fits, if it doesn't fit, what's the well done? It's invalid. It is not valid because the ROA has a strict rule that says the max length is 21 for this /21. So I see Simon taking the lead, 100 points ahead of TDK and close to Felix. Next one, we're close to the end. Which BCP is about anti-spoofing? Is it BCP 38, BCP 58, BCP 89, or BCP 68? This is very simple. This is a very simple question. Let's see. It's BCP 38, not 50 and not 78 and not 89. Ooh, let's see. How did it go? Wow, well, positions have changed on top. Nice. Felix, Tony, everyone is very close. That's a very close call. So let's see the next question then. A ROA is invalid if the max length is not correct, the prefix is not correct, the certificate expired, or the AS number is not correct. Ooh, this was also pretty tricky because it's about the ROA. ROA can be invalid if the certificate expired, but it doesn't have anything to do at this point yet with max length, with prefix, or the AS number. So let's see how it went on top. Simon's still on top with a very close Tony, RTR, and TDK, and Felix. Okay, so we still have 2 questions to go. No, this is the last question. In RPKI delegated mode, who generates and manages the private key? Very last question. Is it the LAR and the member, the user of the websites, the RIR, or both the RIR and the LAR member? LAR or member. This can also be a tricky question. Oof, it's the LAR and the member. You generate your own private key in your own CA, and then you have the public key signed by the parent. Let's see if anything changed on top. Okay, so third is Tony.
Woo!
Then we have RTR. And then on top we have, who's the winner today? Simon. Simon is actually not very far from me here in Switzerland. So let me take a screenshot here.
Congratulations.
Congratulations. Congratulations. So I've taken a screenshot, but let me replay the animation because then I can do I can take a screenshot for the first whole 5. RTR and then last. Because then I have the first 5 because we have voila, TDK and Felix. So please get in touch with my colleagues. Well, with us. I know Megan should be maybe putting an email address. Okay, send an email to Megan if you are amongst the first 5. We will check who you claim you are. And then there are prizes for you. For the first 3 should be, I don't want to promise too much, but it should be a remarkable, and then t-shirts and other gadgets for the first 5. Thank you very much, Melchior. Thank you very much, everyone else, for being here today for the quiz and for staying with us for the RPKI week. I see many faces I've seen across the whole week from Monday until today. And I'll leave it back. I'll hand it back to Melchior for the closing remarks.
All right, thank you, Max. That was an excellent quiz, and a bit tough, I should say. But thanks for organizing it. Thanks for joining. Thanks again, Den, for presenting today. And of course, thank you all for joining this session. I'm sure that if there's any questions with regards to the presentation from Den, that he's happy to receive your emails. And of course, thanks to ISOC for organizing this excellent RPKI Week 2022. It was great seeing you. Thanks. See you next time. Bye-bye.
Recording stopped.
Hello. Hello.